Hello everyone. In this lecture, I'm going to show you how to find the orbital radii of the moons of any planet using the awesome Celestia. Okay, let's take a look at how we can do it. Now, using Celestia, we can find the orbital radius of any moon using simple geometry. Let's take a look at Jupiter and its moon Io. Now, Io is orbiting Jupiter in a circular orbit that goes around like that. And these are the semi-major axes of the moon. Let's fly our spacecraft close to the moon. And we are here in the spacecraft. The distance to the planet is given by this line, and the orbital radius is this arrow right there. So this is a circular orbit, and we can find the orbital radius like that. Celestia will also give us the distance from your spacecraft to the moon. So knowing the distance to the planet, knowing the distance to the moon, the radius of the planet and the radius of the moon, we can find the orbital radius pretty easily. Let's take a look at the details. Now you are here in a spacecraft looking at Jupiter and its moon. The orbital radius is right here, this red arrow. Celestia will give you the distance from your spacecraft to the surface of the moon, and also Celestia will give you the radius of the planet RP. Celestia will also give you the distance to the moon and also the radius of the moon. While using Pythagoras theorem, we can find the orbital radius pretty easily by adding the distance of the planet, dp, and the radius of the planet, square it, and adding to the distance of the moon plus the radius of the moon square. Let's see how we can do that using Celestia. Here is Celestia. If you don't know what it is, or what will it do and how to download it, you can watch my previous video. This awesome program is free. You can download it. If you don't know it, watch my earlier video. So here is the Earth. When you first start Celestia, you will see the Earth. Let me go over some of the more important information. Upper left-hand corner, you can see the object that you have selected right now is the Earth. It will also show you the distance from your spacecraft to the Earth's surface. The radius of the Earth is given right here, 6,378.1 kilometers. And the apparent diameter is the angle, and all that we don't need at this point. Also, down here is the field of view. Right now it's 30 degrees and 58 minutes. That's what we need as well. Okay, so let's go fly to Jupiter. Jupiter is the 5th planet in the solar system. All you need is type in 5 and you can see Jupiter. And let's hit go, G for go. And our spacecraft will fly to Jupiter. So here's Jupiter. Right now, currently your distance from your spacecraft to Jupiter is 285,970 kilometers away. The radius of Jupiter is 71,492 kilometers. See what we can do. Now we're looking at Jupiter, and Jupiter is kind of big. You would like to be able to not only see Jupiter, but its moons. Let's use our mouse wheel. You can zoom out, and you can see the moons are moving. Zoom out is actually moving away. If you look at the distance, as you zoom out, you are moving away from Jupiter while maintaining the same field of view. So your camera angle is the same. Right now, you don't know which planet is which. It will be nice to turn on its orbit and turn on its label of the moon. Let's hit M. You see 2 of the planets right here. If you zoom out more, you can see more of the planet Europa. Ganymede, these are 4 biggest moons And I would like to be able to see the orbit as well. Hit O for orbit. Can you see all these orbits are currently oval? It would be nice to be looking at Jupiter from its north pole. We can do that. Let's navigate to the object. Right now it's Jupiter. Latitude is 90 degrees. Longitude is 0. That way we will be looking down its north pole, and the distance, I'm going to keep the distance the same. Let's hit go to. Now we're flying our spacecraft, looking directly at the north pole of Jupiter. Now let's look at our first moon. Here is Amalthea. That's the moon right there. And let's record some information. Right here, I have already created an Excel spreadsheet, and you can do the same. So this is an Excel spreadsheet that I've created. This is orbital radii of the moons of Jupiter, and I'm gonna create a column to put down the names of the moons. I've already recorded 2, Io and Amalthea. Planet, distance to planet, radius of planet, and distance to the moon, and the moon's this will be the moon's radius. And orbital radius right there. Okay, so let's record some information. If you want to go to somewhere else, certainly we can. Let's zoom out to look at Io. Io is right there at the edge. So let's record some information. Currently, my field of view is 30 degrees. 30 degrees is fine as long as your field of view is not too narrow. You are not sacrificing the accuracy. So I would suggest anywhere above 30 degrees will be good. Okay, so the current distance is distance from the spacecraft to the moon, to the Jupiter is 1497600 kilometers. So 1497600. 1497600 is my distance. And let's look at the radius of Jupiter is 71,492. 71,492, that's good. Let's look at the distance to the moon. I'm going to use navigation. Select object. This object is Io. All you need is put in Io and hit OK. And right now it's displaying the information about Io. Io belongs to Jupiter. The distance currently is 1623000. 1623000 kilometers. And I can also put down Io's radius 1821.6. 1821.6. Now we can use our equation of Pythagorean's theorem. Here is the radius. You can put in square root of what? Well, square root of the distance to the planet plus the radius of the planet square, and then minus the distance to the moon plus radius of the moon square. That will give you the orbital radius. I did the same for another moon, and you can also look up the information from JPL's website. All right, let's see how well we did. I also added 2 columns. This is radius from Jet Propulsion Lab or anywhere you can find information, and I added also a column of percent difference. So right now my orbital radius is 421,895.16 kilometers. So let's go to Google for help. Here we go. We're going to look for orbital radius of Io. Pretty easy. Let's go. Let's go to Wikipedia. There we go. Wikipedia. Io is right here. Pretty good looking planet. If you scroll down, you will see orbital period, and you see mean orbital radius 421,700. And what did we get? 421,895. So let's put that number in. 421,700. Let's look at the percent difference. The percent difference is the difference. So let's do absolute value of the difference between these two number we got from Celestia minus the number we got from Wikipedia, dividing, let's pretend their number is more accurate, dividing by what's from NASA, and that's our percent difference. Let's change that into percent. Whoa, that's 0%. Let's expose. Is 0.05%. Isn't that awesome? We just found the orbital radius of Io to within 0.05%. Hope you enjoy and find more orbital radii of different moons. Have a good day.